Welcome everybody to module 4 practical numerical methods for sciences and engineering. We are still in root of system of equation. Today we have new method to solve roots of system of equation. It's Gauss elimination method. So this method comprises of two steps. The first step is forward elimination, in which we can cancel or remove the constants to have only one equation with one unknown. So we remove the unknowns, and if I have, for example, examples plus. So if equal, so if I cancel 2 and keep one only equal 1, so I have only one unknown and one solution, and then I can use it in the previous equation to substitute to find the 2, and then backward to solve all the unknowns. So unknowns are eliminated by multiplying the equation by a constant and then combining the two equations together, so the result will be one equation by one unknown. And after that, the second step is back substitution. So equation is solved for x, and then the result is back substituted for the previous equation until all x are found. So let's practice this one now. So for example, I have this equations of two unknowns and I want to solve it. So my aim is to cancel this one to make it 0. So then I can find x2 by dividing this constant over this constant. Once I found the coefficient of x2, I can substitute it here, so then I can find the a1 1. Okay, so this is my target or my objective. Okay, now how to perform this? We have two equations, so we will multiply a coefficient to equation. So since this is the equation, I want to play with it. Okay, so it will call manipulated equation, and this one will be a reference equation or pivot equation. So now I have pivot equation and I have manipulated equation. The pivot equation is the first one and the manipulated equation will be the second one. I will play with it to convert the coefficient to 0. Okay, now, so how to do this? So consider this equation, you can use it. Okay, pivot coefficient, it will be this is pivot coefficient for x1 and pivot coefficient for x2. Okay, so pivot coefficient times, this is the constant. If you remember, we said the equation should unknown should be multiplied by constant. Okay, now since we will not play with this equation will keep as it is. We'll not play with it. We just do this manipulation, or this equation will be applied for the only manipulated equation. Okay, so pivot coefficient, so it will be the first one, okay, times minus the constant, it will be constant of the eliminated equation, this one, over pivot equation, coefficient of the pivot equation. So this will be constant every time, plus manipulated coefficient. This is manipulated coefficient. Okay, so when you go for the second item, so where is my pivot coefficient? This is my pivot coefficient. Okay, times minus eliminated coefficient fixed, so this will be 1. This one I will want to eliminate it, over the pivot coefficient, so this one, because it will be constant, it will not change, plus manipulated coefficient. Where is manipulated coefficient? This time will be a22. Okay, so let's take a real example. Okay, now here we do it. Now we have these two equations. Okay, so my pivot, what we did here, so we kept the first equation as it is. Okay, and for the second equation we said a11, this is a pivot coefficient, okay, times minus a, this as you can see, this is coefficient is constant for both, so it will be eliminated coefficient, this is eliminated coefficient, my over pivot coefficient plus the here the pivot coefficient, okay, plus, sorry, eliminated coefficient, so it will be here a21 plus a22, okay, for the second one. So here when you do this one will be eliminated, okay, but this one will be change the value, so the value instead of a22 it will be a dash, so the coefficient will be changed, and also the b should be applied the same, so we should apply this coefficient also for b, so this b will be b plus b dash, okay. So now for more complicated equation, like for example we have 3, it will be in multi-step, okay, it will be in multi-step. So first we have this equation, so we make like forward elimination. Forward elimination will apply the forward elimination for this equation and this equation together, this equation first and this equation, so we have both are 0, okay, and we have a dash a dash a dash a dash a dash b a dash and b plus. Then after that we can we can consider this equation as a pivot equation and manipulate with this one, okay. So by this we have this equation will be a double dash and b double dash, okay. Now we have only one unknown and one unknown, okay, so we can find this coefficient and then we can back substitute it to find the previous one and so on. Okay, now use Navier-Stokes elimination to find roots of the following equation. Can you try it? Here we have codes for MATLAB code for Navier-Stokes elimination method. We want to apply it to perform Navier-Stokes elimination method. Please, just I want from you to pay more attention here because it's a little bit complicated. And it needs more concentration. Even if I describe each one, you maybe still cause some confusion for you. So I recommend that you can try it by yourself, and even you can test item by item. And but here don't stop the echo printing, remove it to see how it performed one by one in MATLAB. So this can give you more deep thinking about what happened inside. But here let's explain the major idea. So here we want to put input matrix, so this is the coefficient matrix as AB, okay, and so A will be the coefficient matrix and B will be the right hand vectors, okay, B. It's very important for Navier-Stokes elimination method to have check the dimensions to be square, should be square matrix. If is it not square matrix, it can't find a solution. So in order to check the matrix, we here created M and N equal size of A. So now he will check the size of A and put it here as M and N, okay. Now M, for example, if I have 3 times 3, so it will be M will be 3 and N will be 3 as well. If M doesn't equal N, then error and matrix must be square end, and the loop will end, okay. Now if not, we can start our iteration method or our way to solve it. So we need first to combine A and B together in the same matrix, because we will apply the elimination to the matrix. So here we created a new matrix called AB, and this AB is A and B, so it will be A and B. Okay. Now we already defined n as a number of column, but actually we will apply some calculations to the vector as well, okay, to the right hand vector. So it's important to identify nd equal n plus 1, so the process will continue until the vector. Now we want to make a process for forward elimination. So in order to proceed forward elimination, we need to extract the reference coefficient and target coefficient. Reference coefficient, this is a pivot. We call the pivot, and the target is the eliminated coefficient from the matrix. Okay. Now we used for loop to start the process. So for k equal 1 until n minus 1, do the following. So why we said n minus 1? Because we want to perform to the elimination to all x's just before the last x, because if you cancel this one you can solve, because you have no unknowns. So we want to perform if we have x1, x2 and x3, so you want to stop until to have this 0 and this 0 and stop at the last x. So here we set from k equal 1 until n minus 1. For this we can another loop, we put another loop, for I equal k plus 1 until n. We used here, remember that I equal k plus 1 over n, we use I to identify the row number. So since I want to extract the target, or I want to play with the manipulated cell, and the manipulated equation always become below the reference or the pivot equation, so I should I always put plus 1, because this equation come plus 1. Okay. Now for I equal k plus 1 until n, as we said here, because we want to use it to extract the manipulated equation below the pivot equation. Now let's identify the factor or the constant that we will use to multiply. So it will be equal minus 1, minus 1, because here we have to use minus 1, and here we have to eliminate it over pivot. So let's go here. So it will be ab is a full matrix, and then I will extract I and k. So we'll extract I, because I and k will extract. We want to eliminate coefficient, so we'll take this eliminated one, I and k divided by k. So here I is the number of row and k is the number of column. Here both row and column, but will be k. So because we will use it for multi equations, so we should do this, to calculate the eliminated factor. Now we found the eliminated factor. Then here for the matrix AB from I, this is number, because now I want to to apply the coefficient. So I from K until ND, because I will apply the substitution for all matrix, okay, even for the right hand vector, equal, okay, abs ab equal to from K to K until end. As we said, we want to extract all the substitutions, times vector, this is a times factor, this is a factor, okay, plus AB from I to K until ND, and this is to apply the Navy elimination. End for 4 and end for the second 4, so it will apply for whole matrix. Now we make all the sorry, for the back elimination, forward elimination. Now we want to go again for the back substitution. Okay, in order to do the back substitution, we have first to create a matrix. This matrix is ones for n, so it will be all 1, because you can do substitutions with matrix that doesn't have the same size of your own matrix. Okay, so now, so this is to identify x that will be used in the loop. So you can identify it as 0, also you can use as 0 or 1. Now you want to identify, you want to start from x3, you don't want from x2, or suppose that you have a bigger matrix for 4, x4. So how can we start with the largest one? We can start with the largest one by put xn. So n is what? N is the matrix, is the size. So if it size x3, so it will be n will be 3. If it 4, it will be 4. So xn will be the largest x in the matrix. So it will be how to, now we want to divide it to find the x3, for example. So it will be AB. Okay, AB is the whole matrix, A and B, N and ND. So N will be the this is, we said this is the number of row. Okay, so this is the largest row, there is X, and ND is the largest column. Okay, divided by the coefficient of N and N, so this will be for 3. By this we found X3. Okay, so why you do this again? This is to find the coefficient of the largest x in the matrix in order to, now we want to find the other x n minus 1. So now we can make it the loop. So for n minus 1, so that's mean for x2 or x1 until I want you to just check this one. So we will keep 1 by minus. Okay, so n minus 1 until 1 by going one step backward. Okay, minus 1. Okay, what should do then? xi should be equal to ab I nd minus ab I until I plus 1, okay, until you reach n, times x plus 1 until n overall divided by a b I know this step maybe you can find it very complicated, but this to apply the back substitution for all steps. Okay, then end and display x. Okay, the best way to understand it, you can, if you want to understand how this step has been performed, just please you can remove this echo stop, okay, and check how MATLAB perform it, so you can check what is happening. Okay, or you can do it by have a paper with numbers and check one by one how it can be performed for it, so you can deep understand what is going on behind these codes. Now, to find the root of this equation, okay, so we just apply, we load the software, insert the coefficient matrix, we put all of them, and then insert the right hand vector, so we also put them, so it gives me the solution of the x1, x2, and x3.